Hello, calculus fans. Okay, so now we're going to talk about inverse trig functions and their derivatives. So in pre-calculus, we talked about which functions have inverses. And one of the things that we learned about functions and their inverses is that only functions that are one-to-one have inverses. Now we can tell which ones are one-to-one by looking at graphs. The ones that pass the horizontal line test are one-to-one and therefore have inverses. Now we'd like to do this with the sine function. Unfortunately, the sine function is not one-to-one because it doesn't pass the horizontal line test. Well, let's look at the picture. Okay, so here's a graph of the sine function. And we've also thrown in a red line. This is a horizontal line. That's the line that illustrates the fact that this function is not one-to-one because it doesn't pass the horizontal line test. Remember what the horizontal line test says. If any horizontal line hits the graph more than once, then the function is not one-to-one. All right, so here it's pretty easy to see. Not hard to draw a horizontal line that hits the graph many times, infinitely many times, in fact. Okay, so the sine function is not one-to-one. But we still want to be able to talk about the inverse of the sine function. So there's a fix. And the fix is that we're going to restrict the domain of the sine function. So for instance, if we just take the portion of the graph between negative pi over 2 and pi over 2, then the function is one-to-one. So basically, we're going to chop it off here and only take that portion of the graph. Well, let's see what that looks like. So what we're doing is restricting the domain. We're saying we're only going to be allowed to plug in values between negative pi over 2 and pi over 2. And if we do that, now we've got a graph that passes the horizontal line test and thus is one-to-one and thus has an inverse. So our restricted function has an inverse because it passes the horizontal line test and thus is one-to-one. Now let's also recall the definition of what an inverse function is. Essentially, the inverse function is switching the inputs and the outputs. So we can say that f inverse of x is equal to y if and only if f of y is equal to x. So let's phrase this in the context of the sine and the arcsine function, the inverse sine function. So I'm going to call this inverse function arcsine. So arcsine of x is equal to y if and only if sine y is equal to x. And it's important that the value of y has to be between negative pi over 2 and pi over 2. So we're restricting the inputs into this sine function to be between negative pi over 2 and pi over 2. Then if we want to define what we mean by the arcsine, then we'll say that if we choose a value of x that's between -1 and 1, then the arcsine of x is the number between negative pi over 2 and pi over 2 whose sine is x. Now we're picking values between -1 and 1 because that's the range of the restricted sine function, which means that becomes the domain of the inverse sine function. Now just a quick word about notation. This book, and a lot of the others that we're using, uses the notation sine with a -1 power for the inverse sine of x. I hate this notation. I would strongly discourage it. It's very easy to confuse this for the reciprocal of sine x, that is a -1 power. And the reciprocal of sine x is cosecant of x, which is a completely different thing. The arcsine function is not a multiplicative inverse. It is a functional inverse of sine of x. Those are two very different beasts. Now, our book uses this notation, sine with a -1 power, but in these videos, and on any homework problem or exam problem that I write, I will always write arcsine of x, and I would strongly suggest that you do the same thing. Okay, that's all for now.